Section 9.4, the point slope form, y minus y sub 1 equals m times x minus x sub 1. In this video, we are going to graph a line given its slope and 1 point on the line. We're going to use the point slope form to find the equation of a line given its slope and a point that lies on the line. We're going to find the equation of a line if you are given 2 points on the line. And we're going to recognize and know how to find lines that are parallel and perpendicular. Let's start with the example that we have to graph a line with a slope of -3/4 and passes through the point 2, 5. So let's first of all start by plotting our point. Since we know that it starts at 2, 5, then we can go over 2, up 5, put our dot. Then if our slope is -3/4, well, remembering from our previous video, slope is rise over run. And if our rise is -3, then that means we're going to go down 3, and then we're going to go over 4, and going to put a dot, and that's going to be a second point that has to lie on that line. Since we have a small graph paper, we're going to go ahead and just connect those dots and form the line that would pass through those 2 points. Now let's talk about what we mean by point slope form. Point slope form is of the form y minus y sub 1 equals m times x minus x sub 1. Whereas before, m is going to be our slope, and then the point x1, y1 is going to be an ordered pair that we know that lie on that line. So let's write the equation of the line that has a slope of -1/2. So we know m is -1/2, and it passes through the point 2, 3. Well, that's an x1, y1. And then we're going to graph that line using the point and the slope. Well, using point slope form, we can now substitute in y minus y sub 1 is 3 equals m, which would be -1/2, x minus x sub 1, which would be 2. Now we can graph that line by starting with our ordered pair at 2, 3. So let's plot our point, and then let's count off our slope. So since our slope is -1/2, we're going to go down 1, over 2, put a dot. Then we'll go down 1, over 2, put another dot. We could also go up 1 and over -2. And now we have a few dots, and we can connect those dots to make our line. So there would be the graph of the line. Now, one of the things that we can do when we have point slope form is we can also switch that to slope intercept form, which, if we remember, slope intercept is y equals mx plus b. So even though the problem doesn't ask us to do that, let's take a moment and do that. So if I do y equals mx plus b, what I would want to do is go ahead, and since I have a number out in front of my parentheses, I can do distributive property and get -1/2 x, and then -1/2 times -2 would be +1. But since we're trying to get the y by itself, let's add 3 to both sides and get y, those are going to cancel, equals -1/2 x plus 4. Now if we remember from slope intercept form, our slope is -1/2 and our b is 4, which that's where we touch our y-axis. So if we look at our graph, we do touch the y-axis at 4, so there's my b. And if I count my slope down 1 over 2, notice that I get the same points that I previously had using the point slope form. Now we want to look at what do you do if you need to write the equation of a line given 2 points. Well, when you write the equation of a line, you need to know what the slope is. So the first thing you're going to do is if they give you 2 points, you're going to use your slope formula that we've talked about before, and we're going to calculate the slope. Then we're going to pick one of our 2 points, and it doesn't matter which of the 2 that they've given me, and I use it and my slope, and put it into the point-slope form to write the equation. So let's look at this example. We have 2 points, -1, 2, and 4, -2. So let's label those as x1, y1, and x2, y2. So the slope is y2, let's go ahead and write our formula down, minus y1 over x2 minus x1, which would be -2 minus 2 over 4 minus -1. But that's going to be -4 over 5. So our slope is -4/5. So I would have y minus my y point. So I just pick one of these 2 points up here as my x1, y1 or x2, y2, and it doesn't matter which one, but I pick one of those, and I'll go ahead and use this first one and substitute it in for x1 and y1. So remember that point slope form. We'll go ahead and write it down. Looks like that. So we have y minus y1, but y1 was 2, equals m, -4/5, x minus x1, which would be minus -1, or we would normally see that written as x plus 1. Now we're going to take a minute and talk about parallel and perpendicular lines. First of all, we need to understand the definition of parallel lines. Parallel lines that are 2 lines that lie on the same plane and they never intersect. In other words, they never cross each other. Parallel lines always have the same slope. It's important that we realize that all vertical lines will have to be parallel to each other and all horizontal lines will be parallel to each other. If we talk about perpendicular lines, they are lines that are going to intersect at a 90-degree or a right angle, and their slopes are going to be negative reciprocals of each other. And it's important again to note that horizontal lines are always perpendicular to vertical lines. Now let's apply what we just talked about to discuss some slopes of parallel and perpendicular lines. So we want to find the slope of the line that is either parallel or perpendicular to the given line. So I want the line that's parallel to y equals 3x plus 4. Well, since we are in slope-intercept form, we know that the slope would be 3. So the slope that would be parallel to that would have to also be 3 because parallel lines have the same slope. Now if I want the slope that's perpendicular to 1/2 x plus 5, the slope of the given line is 1/2. So to be perpendicular, we said you have to be opposite reciprocals. So that means we have to change the sign. So since this is positive 1/2, we now make it negative, and then do the reciprocal, which would be 2/1, or just -2. In the next equation, we want to be parallel to 3x minus 4y equals 16, but I don't know the slope when I'm in that form. So what I'm going to do is I'm going to solve for y equals. So we'll subtract 3x. So -4y equals -3x plus 16. Remember, we want our x term first. Divide by -4. So y equals positive 3/4, because -3 divided by -4 would be positive 3/4 x. And then 16 divided by -4 would be -4. So since the slope of the given line is 3/4, the parallel slope would also be 3/4. And in the last one, we want to be perpendicular to 2x plus 5 equals -20. So again, let's do the same thing and solve for y equals. So we'll subtract 2x. So 5y will equal -2x minus 20. We'll divide by 5. So y will equal -2/5 x, and then -20 divided by 5 will be -4. Now the slope of this line is -2/5, so then the slope of the line that's perpendicular to that would have to be the opposite reciprocal, so it'd be positive 5/2. In example 5, we're going to find the equation of the line that passes through the point 2, 3, and is parallel to the line 5x plus 3y equals 1. So let's start by taking 5x plus 3y equals 1, and we'll go ahead and solve for y so we can find our slope. So we'll subtract 5x divide by 3. So y would be negative 5/3 x plus 1/3. So the slope of the line that I was given is negative 5/3. So that means that the parallel slope is also negative 5/3. So my equation becomes y minus, so we come up here, this is my x1 and my y1. So y minus y1, well that be 3, equals m, my slope, negative 5/3, x minus x1, which would be 2. And then it asked me to graph those two lines. So let's take a moment and graph the one that we originally were looking at. So if we started at 2, 3, that puts my dot there. Then my slope is negative 5/3, so we're going to go down 5 over 3. So if I draw the line between those 2 points, it's going to look like that. My second line, which actually is the original line, I have to use this to graph. So we know that m is negative 5/3 and b is 1/3. So we're going to start just a little bit above 0. And then we're going to use our slope of negative 5/3. So down 5 over 3. And what should happen is when I connect those two dots, I'll notice that my two lines should be parallel to each other. In our next example, we're going to do the same kind of thing, but this time we want to be perpendicular to the line 5x plus 3y equals 1. So we've already solved for y equals a minute ago, and we got that y was equal to negative 5/3 x plus 1/3. So the slope of that's negative 5/3. So the perpendicular slope would have to be positive 3/5. So my equation becomes y minus, and again, we've got x1 and y1. Y minus 3 equals m, x minus x1, which would be 2. Now, if we graph the two lines, looking at our first one, we were going to start at, we know m is negative 5/3, and b is 1/3. So we're going to start at 1/3, and then we're going to go down 5 over 3. Okay, and then we connect that. Then my second line goes through the point 2, 3, and I'm going to have a slope of 3/5. So we're going to go up 3 over 5. Notice I'm going to have to go off there. Or we could go down 3 and over negative 5. And when I graph those points in a line, what I should notice is that I've now formed a right angle, which is what I meant to have because these lines were perpendicular. Quickly, let's summarize everything we've talked about in discussing our formulas and properties for straight lines. First of all, we have our different forms. You have 3 different forms you need to know. Standard form is ax plus by equals c. Slope-intercept form, y equals mx plus b. And point-slope form, y minus y1 equals m, x minus x1. You also have a formula for how to calculate the slope. So if you are given 2 points, you can use this formula to calculate the slope. We know that all horizontal lines are of the form y equals a number and they have a slope of 0. We also know that all vertical lines are of the form x equals a number, and they have undefined slopes. Then we just discussed the fact that parallel lines will always have the same slope, and perpendicular lines will have slopes that are negative reciprocals of each other.